Hello everyone, I'm Kuya Ed. This video is all about solving problems involving permutation. Let's solve problems involving permutation. The first type of permutation is permutation of distinct objects without repetition. Let's give for an example. How many permutations can we have 0 to 9? The first that we're going to do is write the formula for this problem, which is P quantity of n is equals to n factorial. Next is we have to substitute n, which is 10. So since when we count 0 to 9, the total number of objects will be 10. So P quantity of 10 is equals to 10 factorial. 10 factorial is equals to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Let's multiply all this number, so the result is 3,628,800. So let's come now to the second type of permutation, which is permutation of distinct objects with repetition. For an example, how many ways can a 4-letter password be generated from the alphabet letters if a letter can be repeatedly? We're going to find what is n, which is the total number of objects. So n is equals to 26 since we have 26 letters in alphabet. Then next is find what is r. R is equals to 4. To solve this problem, we're going to write the formula, which is P quantity of n is equals to n raised to r. Let's come now to the substitution. So P quantity of 26 is equals to 26 raised to 4. Let's simplify. 26 raised to 4 is equals to, yes, that's right, 456,976. Now, the third type of permutation is circular permutation. For example, how many ways can 6 persons be seated around the circular table? First is we're going to find what is n. So n is equals to 6. To solve this problem, we're going to use this formula, which is P quantity of n equals to quantity of n minus 1 factorial. Then let's substitute n, which is 6. So P quantity of 6 is equals to 6 minus 1 factorial. 6 minus 1 is 5. Then copy the factorial sign. 5 factorial is equals to 5 times 4 times 3 times 2 times 1. After that, we're going to multiply all these numbers. So the answer is 120. This type of permutation is the permutation of similar objects. For example, Donna has 4 yellow balls, 3 blue balls, and 6 green balls. How many ways can she arrange the ball in a row? We're going to find the n, which is the total number of objects. So n is equals to 13. Since we have 3 different color of balls, so we're going to divide them into 3 R. R sub 1, R sub 2, and R sub 3. R sub 1 is equals to 4 yellow balls. And R sub 2 is equals to 3 blue balls. And R sub 3 is equals to 6 green balls. To solve this problem, we're going to use this formula, which is P quantity of n is equals to n factorial all over the r sub 1 factorial, r sub 2 factorial, and the r sub 3 factorial. Let's come now to the substitution. P quantity of 13, since 13 is the n, equals to 13 factorial all over the r sub 1 is equals to 4 factorial, then r sub 2 is the 3, so 3 factorial, then r sub 3 is the 6, so 6 factorial. Going to simplify, so 13 factorial is equals to 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1 all over the 4 factorial is equals to 4 times 3 times 2 times 1. Then the 3 factorial is equals to 3 times 2 and times 1. Then 6 factorial is equals to 6 times 5 times 4 times 3 times 2 and times 1. To make the number lesser, cancel out the common number. So cancel out this one and this one, and thinks all numbers in numerator that can divide to the denominator. So 12 and 4 times 3 will be cancelled out. Then the 8 in the numerator, then the 2 times 2 in the denominator, so you can divide that. So 8 divide 4 is equals to 2, then 9 divide 3 is equals to 3. So after that, all you have to do is copy the remaining numbers. So the remaining numbers are 13 times 11 times 10 times 3 times 2 and times 7. So multiply all these numbers, so the answer is 60,060.
Let's do this.